Very good morning friends, and in this video we are going to discuss about the solution of triangles. As you all know, the triangle is a plain three-sided figure and it has three angles and three sides. So when we talk about the solution of the triangles, actually what we are saying that we have to find the angles and then the sides. And if you know that if you find the angles and the sides, you can find the area of the triangle as well as the perimeter of the triangle. So these are the things which we study and which we call as solution of the triangle. Now first in this series, here we'll discuss about the sum rule, like the sine rule and the cosine rule, projections, etc. So now in the first idea, I try to introduce you with what is called as sine rule. So the idea goes something like this. First let me make a heading, that is solutions of a triangle. Now, so just see, this is one case. This is a triangle ABC, which is a acute angle triangle. A acute angle triangle is a triangle in which all three angles are less than 90 degrees. So this. Then we can have one right angle triangle. This is a right angle triangle. A, B, C, and right angle at B. Now another one we can call it as obtuse angle triangle. So it goes like this. So in obtuse angle triangle A, B, C, here this angle is more than 90 degrees. But if you want, because if you want to apply the T ratio, the triangle needs to be so I need to make it a right angle triangle. So this is already a right angle triangle, no construction is required. Here I need to draw one perpendicular from A onto the side B, and I name it as D. So AD is perpendicular on this. Here if you drop a perpendicular from this, it will not go inside this, it will have to come outside, and that will be on the extended part of the triangle. So this is D, this is 90 degree. Now I just simply apply the T ratios. So here in this triangle I say sine of C, sine C. We don't need bracket, sometimes we can write the bracket also. Sine C is opposite, which is AD upon hypotenuse, that is AC. So we get AD equals AC sine C. Now we know that there is one kind of notation where we represent the sides of a triangle, like this is the vertex A. So the side opposite the vertex is small a, and this is small b, and this is small c. This is small c, side just opposite the vertex C. Same way, A is here, B is here, and the C is here. Here also we have B, and we have A, and we have C. So we can say AD is, AC is what? What is AC? That is B. So this becomes B sine C. Now AD. Same way, now apply the same sine rule in this triangle ADB, means in this part of triangle, this one. So we find sine B equal to opposite, that is AD upon AB. So this will become AD equals AB sine C, and AB is small c. So sorry, this is sine C, this is sine B. So this is C sine B, C sine B AD. Now you see this is also AD and this is also AD. So if you apply, so if you say these two ADs will be same, like this AD is same as this AD, therefore we have B sine C equals C sine B. Then we can have sine C over small c is sine B over small b. Similarly, if you drop a perpendicular from this onto this side, then you can find one more relations, and then on the basis of that you can find sine A upon A. So this rule is called as sine rule, and you can do the same thing in all these triangles, and every time you will find this relation, and this is called the sine rule. So the reciprocal of this is also called because it's a ratio, three ratios. Sine C over C equals sine B over small b is sine C. Sine of angle, the ratio of sine of angle of a triangle to the opposite side bears a constant ratio. And so if you just use the idea of invertendo, you can have A over sine A equals B over sine B equal to C over sine C. This is one ratio. Again, if I try to represent in the right order, so I can have sine A over A, sine B over B, and sine C over C. So this is about the sine rule, and it has been found that this one is equal to 2r, where r is the circumradius of the triangle. Like if you draw a triangle, then there is a possibility that you can draw a circle, that is called as, means a circle which is passing through all the three vertices of the triangle. This is called as circumcircle, and the radius of this circumcircle is called as circumradius. If I assume this so this 2r is the circumradius of these circumcircles. So if required, if you are interested in finding their circumradius, then you can use this relation where 2r is circumradius of these circumcircles. Means a circle circumscribing this triangle, the radius of that circle is called as circumcircle. So this is our sine rule. Okay, so now we are going to discuss about the cosine rule. So cosine rule is little different. Then how will I find? First I have to draw a triangle, and then I try to put the triangle at the origin. This is my x-axis, this is x-axis, this is y-axis, and this is my triangle ABC. So now assume that coordinate of B 0 0 because this is at origin, and the side notation, this is small a, this is B, and this is C. So this coordinate will be A comma 0. Those who have studied coordinate geometry, those student can very easily comprehend this. If you haven't, then you can watch my previous videos about the coordinate geometry. So, or the rectangular Cartesian system videos also, you understand how the coordinates are located in a rectangular grid. It's also called as a rectangular Cartesian system. So this is A comma 0. Now I have to find the coordinate of this B. So from here I have to draw two perpendicular, one from A to M. Now here it goes. So this is perpendicular, so I need to make it dotted line because this is just a construction, supporting construction. Again I draw one perpendicular here, and the name, the foot of the perpendicular is D. Now remove all this. So here you see this is my perpendicular. Now I have to find this distance AM and AD. So what I'll do, I'll simply use trigonometry. Like how? So I write sine in this, okay, in this triangle, sine C. What is sine C? Opposite, that is AD upon hypotenuse, that is B. So AD is B sine C. What is AD? The perpendicular distance of the point A from the x-axis, that is your ordinate. So it is B sine C. Now I have to find AM, but I cannot find AM directly. So I'll prefer using BD because AM is equal to BD, and I'll take this angle B into the consideration. So since I have to find BD, that is called as the adjacent or the base of the triangle, so I'll use cosine ratio, that is cos C. Sorry. Again, sine C here. Okay. So just let me check whether I'm doing the same thing, because I have to find AD and then sine B, AD upon B. I should not go into this because I have to find this distance. So I'll go sine B. Sine B is AD upon AC because I am finding this distance from origin to this, from origin to the point D. So I need to have this triangle under consideration. This is the triangle ABD. So we are dealing in triangle ADB. Okay, so the sine B, this is opposite, so AD upon C. This should be C and this is C. So, and this should be B. So this is fine. So we have C sine B. So this one was C sine B. Now I have to find BD. So I'll use cos B. So cos B again is adjacent, that is BD, upon hypotenuse, that is C. So this is C cos B is BD. C cos B. You can just make one more triangle, because if you take this, I have taken the acute angle triangle, you can take obtuse angle triangle, you can take right angle triangle. In all these triangles you have to use the same rule. You have to find the vertices and then you can do, because some people say that will this idea be true when the triangle is obtuse? The answer is yes. Mathematics is true, and if it is true in all other aspect. So here I have the triangle, I name it as, this is my obtuse triangle A B C. So this is small a from here to here, because this is the opposite sides. On the basis of that, you can say this coordinate of C will be a comma 0. This is, we are considering it as origin, so this is 0 0. Now, and this is small b, means from here this is my small b. And if I drop a perpendicular, because perpendicular is not there, I drop a perpendicular here, I name it as AD. This is 90 degree. Now since I have to find the coordinate of the point A, so as you know that there's always the perpendicular distance of the point from the y-axis. So this is y-axis, this is y, this is y-axis, and from here if you drop a perpendicular, I call it as M. So we have to find AM, but we can find BD because BD is just as AM. And I have this angle under consideration. However, this is your angle B. So what is this angle? Pi minus B. So in triangle ADB, here, this is the part of this triangle, this is the part of this triangle. ADB, I using this angle. What is this? cos pi minus b is adjacent, which is BD, upon hypotenuse, means this side AB. And what is AB? This is opposite the vertex C, so this is C. So this is C. But the cos pi minus b is minus cos b, so this will become minus C cos b is BD. So this coordinate BD is here, minus C cos b. Now use trigonometry, find AD also. So again we will write sine pi minus b is opposite, that is AD upon hypotenuse, that is C. So sine pi minus b remains sine b, so this is C sine b equal to AD. So this is C sine b. Now I can here also and here also. Here we have the AC, so we'll use the same formula in both the cases and get the same answer. What is the idea? Idea is that AC, length of AC is B. Now we will find the length of AC using coordinate geometry, the distance between the 2 points whose coordinates are suppose x1, y1. This is x1, y1 and x2, y2 respectively, can be found using the formula under root x2 minus x1 whole square plus y2 minus y1 whole square is B. So what we'll get? We'll get, this is x2 minus x1, so you can say a minus, because a minus b whole square is always b minus a whole square, so you can go in any order, there's no difference. So this is, I write c cos b minus a, c cos b minus a whole square plus c sin b minus 0, that is c sin b minus 0 whole square, and this is b. Now I have to square both sides, so I need to some space. So I think I need to clear this part so that I can. So here I square this equation both sides, so root is gone. So I'll get c cos b minus a whole square plus c sin b whole square equals b square. So here I have to express a minus b whole square, so we'll get c square cos square b plus a square minus 2ac cos b plus c square sin square b is b square. Now here you see c square cos square b and c square sin square b. So if I take c square common, I'll get cos square b plus sin square b plus a square minus 2ac cos b is b square. So this is c square plus, because this value is 1, c square plus a square minus 2ac cos b is b square. So you take this on this side and take on this side, so you get a proper pattern which says like this, that c square plus a square minus b square is 2ac cos b. So I want to clear this part also, just give me, I have to use my duster. So this one we can write as cos b, I make cos b as subject, this become c square plus a square minus b square upon 2ac. This is the cosine rule. Now you see the relation. If you want to derive the other one, so you see cos b. So cos b is, this is your angle cos b, and which are the two sides which hold this angle b, that is this one and this one. So it is a and c. So c square plus a square. So it is when I talk about the cos b, so I'm getting a square plus c square minus b square. Again, I just try to find a reason here so that you can do it easily. This is a triangle ABC. ABC. This is side A, this is side B, this is side C. So now I write the rule. So cos A. Cos A means which two sides are holding this angle A. So this is A and C and B. So just write them C square plus B square minus what is the side opposite A, that is A square, upon again 2 times what the sides which are holding this. So it is 2BC, or you can say 2 times this into this. So again, if I try to find for B, so I write cos B equals to, first it will have minus B square here, because when it is A then A square, so here you will have A square plus C square upon 2 times this and this, 2AC. And then cos C is minus C square, here you can write A square plus B square upon product of these two, so 2AB. And these relations are called the cosine rules. And since this is a relation between the 3 sides of a triangle and one angle, so if 3 sides of a triangle are known, you can anytime find the one angle. This is how it works. Or if any 2 sides and one angle is known, and if it fits the bill, then you can use this rule to find the other unknown, whether it is the sides or whether it is the angle. So this is called the cosine rule. And now here we are discussing about the called projection rule. Projection rule. What it is? So if you have a triangle A, B, C, this is side B, this is side A, this is side C. Now drop a perpendicular AD from A onto BC like this. Then first I use trigonometry to find this BD. So I write in triangle ADB sine B. Oh, sorry, we have to find the base, so we will use cosine. Cos B is adjacent, that is BD, upon hypotenuse, that is C. So what is BD? BD is C cos B. So this is C cos B. Now in this triangle, in triangle ADC, cos C. Cos C is DC upon hypotenuse, that is B. So it is B cos C is DC. So this is B cos C. And now you see this whole length is A, this A. What it is equal to? C cos B, C cos B plus B cos C. Now you try to find the pattern. This A, so when I say C cos B, so C cos B, C cos B plus B cos C is A. So what is B? For B you have this. When you write this B, then if you have to draw the projection on this one, then what do you get? C, because when here we are using C cos B, C and then adjacent. So when I writing here C, then what is C, and this will become the angle. So the C cos A, C cos A plus in this side you will get A cos C, A cos C. And then what is C? So C equal to B cos A, because on C I have dropped the perpendicular like this. This is called as orthocentered. because these are altitudes. Perpendicular drops from the triangle to the opposite sides called as altitudes, and the point of concurrency of the altitudes called as orthocenter. So this is, see, when you drop perpendicular here, then we have this angle. So B cos A. So B cos A plus, then here A cos, because one angle will become this A cos B. A cos B. These rules are called as projection rule.